How are we doing today?
Pretty good.
Okay. So I did get access finally to Canvas, but strangely enough, um, we are unable to delete uh, the Zoom links from get to it either. So unfortunately, uh, so that's good that I actually said that I was going to do it through this by obviously the next class meeting. We'll be able to have changed it because we have to, ask them to give us access, et cetera, to delete it and to allow me to add things. Okay, so I still don't have the permanent Zoom link. The way that you'll be able to tell the permanent Zoom link is that, well, there'll be two things. When you go into, oh, not that class, when you go into this class, sorry. So when you go into this class, one, I'll put it in the syllabus. So right now, obviously the syllabus is blank. And I'll also write it in the announcement. So hopefully, announcements. There, I had assignment rather than announcement. So hopefully people saw that did anyone not see the announcement when they went into Canvas about the temporary link?
Yeah, I got an announcement.
Okay. Yeah, you got an announcement. Okay, so when we're able to fix and get an actual link, I'll put it in saying, now this is the permanent link. I'll also put it in the announcement. Okay. And I guess next time I'll be going over the syllabus. I did put the syllabus in the, in the actual, Canvas. However, there's still things that are blank there because, I don't still have the Zoom and things of that sort. Okay, so let me ask again. Has anyone purchased the college algebra book from Sullivan? So let me ask you. So I'm going to give you some incentive a little bit. If it's okay, since I also noticed with Mario, he actually had listed the pre-calculus in his syllabus as being the book that we're supposed to be using. And also the pre-calculus book is the book by Sullivan that was agreed by the department that should be used for this class. So if there are no objections, we will use pre-calculus by Sullivan. And as a nice incentive, if you just click on the link, there's the book. So you can so I've given you the book. Okay, so I've given you the actual book, so you can you have access to that book as sort of an incentive that since there was an error in the bookstore that they listed it incorrectly, I've given you the current. So this is the 2023 edition. So this is the latest edition of the book. I think it's 2000. Oh, look at that, 2024. It's in the future. So it's 2024. How's that possible? 2024. Okay, so it's a very new book then. Okay, it's a 2023 edition. I don't know why they have it as 2024. Well, sometimes they do that. They put the date there as being a little bit in the future because that's where they think that that's their publishing date. Okay, so it's the latest edition of Sullivan. And so there is a slight difference. And so in the college algebra, what we were going over is the very first chapter was the review chapter, which turns out to be in this book, the appendix. And so in this book here, oh, by the way, can people see my screen? I am sharing, right?
No.
No, I don't see anything.
Are you? I was like, all of a sudden, am I even? Do people even see? You stupid, right? No, 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 you stupid jerk. No, no, no. Could you please hear? Yeah. Okay. I'm sorry. Oh, what an idiot I am. Okay. Okay, so I thought people were seeing things. Okay, so let me start over again. Let's just erase the last 10 minutes or so and just pretend it didn't happen. Okay, so let's just erase that. Okay, so I've uploaded the syllabus. There are one or two little errors that I still have to fix, meaning like the formula that are inside the the syllabus isn't there, so I'll have to put that in. There's like a 20 minutes or something to change, put in the formulas. Similarly, let's see in the modules. In the modules, I do have the. I like to say syllabus there. I do have the syllabus here, and as I said, as sort of compensation for the fact that we incorrectly indicated that College Algebra by Sullivan was the book for this course, whereas it was supposed to be pre-calculus. It's a pre-calculus course, not a college algebra course. Pre-calculus by Sullivan. I gave you the link right here to pre-calculus. So if you click on that, you will have access the PDF to the book. So here's the PDF to Sullivan's book. And as I said, one of the things to notice is that the first chapter of college algebra was called Review. It is the same as the Appendix A in this book. So appendix, it's virtually the same. There's slight differences, but minor differences. So there's a few minor differences, but it's virtually the same as the Appendix A1 review. What did they? I think A8 and 9. So I think something like 7, 8, and 9 are different as compared to what is in the college algebra book. But I will continue with the quote unquote college algebra, the review, and then switch over, if everyone's okay, to start with chapter 1 in the book. So my idea, if there are no objections, and please state if there is an objection, to continue lecturing from the college algebra book, the review, which is the same as the appendix to pre-calculus, modulo some minor changes, where they switch some of those things and put them in other parts of the review. So I was, as I said, the 7, 8, 9 or something are put in other parts of the review as compared to being separate. And then continue with the rest of pre-calculus. Any objections at all? Any objections? So one of the nice things is that now I've given you access to the book. So that obviously alleviates some financial burden that you would have with the other textbook. Any problems at all with that? No objections?
No.
Okay, so good. Okay, so I just want to be sure, because, you know, quote unquote, we're not supposed to change the textbook, but we're not really changing the textbook. We're just sort of correcting the error that was listed in the bookstore. Okay, good. I have started, but not finished the Canvas. So I started working on, obviously I've only had it for access for like one day. So I have input some things for the review. And so I have the review down and chapter 1. So I have the review and chapter 1 more or less completed, and, you know, at least marginally completed. I'll start working on the rest. Hopefully I'll get through another 3 or 4 chapters over this weekend. Okay, so if you look at, let's just say R1, if you want to look at the lecture notes that I had, and I actually gave you the lecture notes last time, you could click here, see where it says at the very top, R1 lecture notes. You would click on that, and those are the lecture notes that I will go over, I did go over in class. Okay, and then there are expanded sort of lecture notes that I've given you. Okay, and obviously I could only work on some of it. Okay, I will next time go over the syllabus yet again when they have everything in place. There'll only be minor things that I would need to cover. Okay, any questions about anything? So if there are no questions about anything, then let me continue with the review section 2, which I think was, oh, let's see what page we're on. 7. Okay, so the review section 2. Algebra essentials. Oh, the assumption is that this is review for people. If, as I'm going through this, you may say, well, I don't quite remember this. Please tell me, and I'll slow down and give further examples. And so, algebra simple, algebra essentials. So we gave an example where we factored out the greatest common factor, in this case, 5yz, and then what remained, 5y minus 3z. We did factoring by grouping, which I said is more of an art than a technique. So in this case, we just sort of guessed by grouping the first 2 terms, the last 2 terms, factoring out what's in common, and factoring out what's in common to be able to factor. I gave you the special factoring properties, which are the same as the special product formulas, except written in sort of the opposite direction. We had the difference of squares. A squared minus b squared is a minus b times a plus b. We had the sum of squares, which turns out to be irreducible over the reals. So a squared plus b squared is irreducible over the reals, meaning I cannot write this as a product of 2 polynomials, neither of which is a unit. And so, you know, obviously I can write this as 1 times a squared plus b squared, but you know, I can't write it as, you know, a product of 2 polynomials. two non-trivial polynomials. We have the perfect square trinomial that a squared plus or minus 2ab plus b squared is a plus or minus b quantity squared. We have the sum of cubes formula. Oh, and why didn't I write it as the same way I did this way? I don't know. Maybe I should write it this way also. We also have the sum and difference of cubes, which is a cubed. Oops, let's do it in black. Just a cubed plus or minus a cubed is a plus or minus b, a squared minus plus ab plus b squared. So this is the sum and difference of cubes. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. This difference of cubes. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. And so we did an example where we factored. This was the difference of squares. So 9 minus x squared, 9 plus x squared. This is the difference of squares. So 3 minus x, 3 plus x. This is the sum of squares. So we could not factor any further. We could not factor this any further over the reals. This was a perfect square trinomial. And so r squared minus 8rs plus 16x squared is r minus 4s quantity squared. And basically, we had a general trinomial, and factoring that, we just used sort of the guessing method. So we factored, well, obviously 3y squared is, there's only one way to factor it, y and 3y. 8x squared, well, it could be factored into x, 8x, 2x, 4x. So we tried 2x and 4x, and we found that 8x squared minus 12xy plus 2xy is minus 10xy minus 3y squared. So yes, indeed, it works. So you basically guess your answer and check that it works. Okay, so any questions about that? Very quick, I know I did it really fast, review of what we covered last time at the end of class. Okay, so now let's continue. So let's do the following example. In each expression, factor the difference of cubes. And so I have here (125) a cubed minus 64. So I remember I just did this. The difference of cubes, here it is. So we had here the difference of cubes formula. A cubed minus b cubed is a minus b quantity times a squared plus ab plus b squared. So let's factor this. So let's take the cube root of 125, 5. Cube root of a cubed, a. Keep the same sign, minus. The cube root of 64. Please do not write the cube root of 64 as 8. For some strange reason, people do all the cube roots correctly, except for the cube root of 64. For some strange reason, students keep thinking the cube root of 64 is 8. 8 squared is 64, but the cube root of 64 is 4. 4 times 4 is 16, times 4 is 64. And now square. And so I have 25a squared, change the sign, plus, multiply. 5a times 4, 28. Plus square, 16. And so I claim that I factored this as much as possible over the rational numbers or over the integers. So in general, when we say to factor completely, we assume that what we're talking about is factoring over the integers. So if we have integer coefficients in the original polynomial, we then have a product of polynomials, all with also integer coefficients. So let's show that this is as far as we can go. There's no further factoring possible. Okay, so let's show that, so certainly we can't factor this any further. This is a linear, polynomial, and there is no common factor other than 1. So let's try to show that 25a squared plus 20a plus 16 is irreducible over the rational numbers. Recall that this symbol here, Q, stands for the rational numbers. Okay, 1 second here. Oops, Dominique, oops. Okay, you were just asleep. You were dreaming. Just go into the other room, please. Stop. You're just dreaming. Okay. Shh. I'm in class. Okay. You're there. No one is here. No one's here. Okay? You were just sleeping. Okay. Oops. Okay, sorry. Okay, so so let's try to show this. So first, let's look at the discriminant.
Oh, my brother. Please,
Wait.
I don't want to be out.
Wait.
Who's out there?
Okay, so recall the discriminant. So the quadratic formula is x is equal to negative. So if you have the quadratic, ax squared plus bx plus c equaling 0, then the solution is x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. And so if the coefficients a, b, and c are real, then we can tell if the solutions are real by just looking at the sign of this. Similarly, if the coefficients here are rational numbers, or in this case, integers, we can tell if the solutions will be rational or irrational by looking at this term. So if the discriminant b squared minus 4ac is less than 0, then the solutions will be complex. If this is a perfect square, then the solutions will be rational numbers. If this is positive or non-negative, well, if this is 0, then it's a double root. If this is greater than 0 and not a perfect square, then you have two unequal irrational roots. So let's look at the sign of the discriminant. Basically, the sign of the discriminant tells us everything. So B 20 squared minus 4A 25, C 16. And so 20 squared is 400. 4 times 25 is 100 times 16 is 1600. 400 minus 1600 is negative 1200. Oh, that means that this is negative. The discriminant is negative. So in the quadratic formula, we're taking, I'll just put a D here. We're taking the square root of a negative number. And we're adding, subtract, and so that gives us some imaginary number that we're adding, subtracting. Therefore, I have two unequal, because I'm adding, subtracting, complex, because we're adding, subtracting a imaginary number, non-real, roots. So therefore, I cannot, for quadratics, I'm therefore unable to factor this over the reals, in particular over the rationals. And so therefore, yes, I factor this completely. Any questions about this?
Yes. Where are they? Where are they?
Okay, here, wait, let's just check.
My head. It's my head. It's my head.
Okay, so
Where did
let's
they go? Where did they go?
you can't.
Where's mommy?
Okay, so any questions about this?
Where did you get 6 square negative 4 AC?
Oh, here it is. I'm sorry. Where did I get what now?
I think 6
You
square
cut out for a second.
6 square negative 4 AC.
B squared.
Oh, B square. Oh,
It's a quadratic formula. Quadratic formula. So it's part of the quadratic formula. It is the formula for the discriminant. So the quadratic formula says if I have a quadratic equation, ax squared plus bx plus c equaling 0, then the solution is given by the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This thing inside the square root is called the discriminant. The sign of this discriminant, tells us basically a lot of things, Obviously, if we're adding and subtracting the square root of 0, we're not adding and subtracting anything. So that means that this is a double root. If this is less than 0, which is this case, then I'm adding and subtracting the square root of a negative number. So therefore, we have two unequal complex roots. Any questions about that? And I apologize for any interruptions during class. Okay, let's continue. Let's do another example. Factor the following expression completely over the integer, over the rational numbers. So again, a lot of times they'll just say factor the following expression completely, with the assumption that you know that we're talking about factoring over the rational numbers or factoring over the integers. If an expression is prime, so indicate. And so I have here x to the 6 plus 7x cubed minus 8. You're like, oh my goodness, this is a polynomial of degree 6. Well, yes and no. It is a polynomial of degree 6. How are you going to factor? Well, they're just trying to fool you. It's really not as difficult as it seems. This is actually quadratic in x cubed. And so really, we'll use the same techniques that we had for factoring quadratics. And this is a monic quadratic. Monic meaning that the leading order coefficient is 1. So because of that, well, that makes our life really easy. And so we have here, well, that's right, x to the 6 is x cubed times x cubed. That's right. I want to find, so now, since this is a monic quadratic, I bring down the plus sign. Plus times minus is minus, so I put a minus sign there. Then I want to find two whole numbers, whose product is 8, and whose difference, because there's a minus sign here, is 7. So give me two numbers whose product is 8 and whose difference is 7. Well, 8 and 1. And if you go with the way I pull down this first sign, then the larger the root with a larger absolute value goes here. So x cubed plus 8 times x cubed minus 1. Any questions on how I factored this? Okay, and now look at this guy. So if I look at this guy here, well, this is the sum of cubes. And so I'll use the sum of cubes formula. The cube root of x cubed is x. Same sign, so it's a plus. Cube root of 8 is 2. X squared is x squared. Change the sign from plus to minus. And then multiply the x times 2, so 2x. Plus, well, 2 squared is 4. And now let's try to factor the x cubed minus 1. So again, oh, well, this isn't so bad. I'm sorry. This is, again, the difference of cubes. So let's take the cube root of x cubed, x. Keep the same sign, minus. Cube root of 1 is 1. Square, x squared. Change sign, plus. Multiply, 1 times x is x. Negative 1 squared is 1. And I claim that I factor this as much as I can over the rational numbers. So now, let's look at the discriminant. So again, as I said, looking at your discriminant, that thing inside the square root in the quadratic formula, tells us a lot about the roots. And so my discriminant, again, is b squared minus 4ac. And so let's show first off that this term here is irreducible over the rational numbers. So I have d is equal to negative to b negative 2 squared minus 4a 1 c 4. And so I have 4 minus 16 is negative 12. Again, this is negative. So I have that, we're adding and subtracting the square root of a negative number in quadratic formula. Therefore, we have two unequal complex roots. So I can't write, so I would have coefficients that were complex numbers, not rational numbers. So no, I cannot factor this over the rational numbers. Now let's show that I can't factor this guy, the x squared plus x plus 1. So I want to show that x squared plus x plus 1 is irreducible. By the way, they also called it prime. So notice that in the book, they said whatever they called that a prime. That is prime. Okay, so let's try to show that x squared plus x plus 1 is irreducible over the rational numbers. And so, well, the discriminant is b, 1 squared, minus 4a, 1, c, 1. 4 times 1 times 1 is 4. So I have 1 squared, which is 1, minus 4 is negative 3, which again is negative. So that means we have 2 unequal complex roots. So again, I cannot factor either of these over the integers. So each of these cannot be factored any further over the rational numbers. I keep switching back and forth. If the coefficients of a polynomial are integer, then factoring over the integer is the same as factoring over the rational numbers. So you'll notice sometimes I switch back and forth between saying over the rational numbers over the integers, because in this case they're the same. But I can't factor over the rational numbers for any of these terms. Therefore, I factored this guy here completely, and I'm done. Any questions about? And so, yes, I factored completely over the rational numbers. Any questions about this?
Professor, a quick question.
Yes.
Yes, I'm trying to see under lecture notes. I have no problem writing all this. I just trying to see under lecture notes on Canvas. Is that accessible? Just
yes. So let's see.
yeah, the
This
modules.
is
There you go.
yeah. So if you go under modules,
Yes.
good. Go under modules. This is R2. Oh, here it is. Go to R2, and there it is, right there.
Okay. When I click on it, yeah, there's this. Yeah, that's the spinning part. So that's normal.
It spins, 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 and there it is.
Okay, so it gets there. Not just it's just on my side, but it pops the. Okay, then it's there. Thank you.
Yeah, eventually it'll pop up. Eventually it'll pop up. They should also, and from there you can also download it. Not only see it, you can also download it from here.
Right.
So you should be able to download it.
Thank you for
Okay.
showing it to me, Professor. Go on.
Sure, no problem. Okay. Any other questions about anything?
Nope, I'm good.
Okay. Oops. Let's do another example. Factor the following expression completely over the real numbers. Ooh. So this is different. So in this case, we're factoring over the real numbers, meaning I want at the end a product of polynomials with coefficients that are reals. It turns out that you should be able to factor any polynomial as a product of linear terms and quadratic terms over the reals. Okay, so it may be difficult, if not impossible, to actually figure out how to do it, but it is theoretically possible. So if an expression is prime, so indicate. So x to the 4th plus 2x squared plus 4. Oh, it almost, so it looks like, well, I can't factor this. So I can't just factor this, any sort of way I try, except for this completing the square technique. So this is so sometimes they call this completing the square. It's an old Greek geometrical term, so a geometrical construct, which turns out, if you write it algebraically, is actually this construct. So this is actually geometry. It's an old problem, meaning like 1500 BC type problem. So if this were a perfect square, then I could, factor it. So let's try to make this into a perfect square. So let's see, how do I make it into a perfect square? Well, let's see, you would take the square root of this, which is x squared, the square root of this, which is 2, and then double it, and then you're squaring it, so it has to be times 2. So 2 times 2 times x squared is 4x squared. So I want a 4x squared here, plus, well, the 4. So this term here should be 4x squared, but we have a 2x squared. So what do? Well, I add 4x squared and subtract 2x squared. 4x squared minus 2x squared is 4x squared. So these expressions are the same. Any questions about that? So I'm basically using the idea that we had from the special product formula, the perfect square trinomial formula, in order to make it so I can factor this term here. And well, I can factor this term, it's a perfect square trinomial, but then I had to add something to it, so I subtract what I had to add additionally from this term. And so x to the 4th plus 4x squared plus 4 is just x squared plus 2. So let's check. X squared squared is x to the 4th. 2 times 2 times x squared is 4x squared. 2 squared is 4. Good. So I'm able to factor this term in the parentheses as x squared plus 2 quantity squared minus 2x squared. Now I look at this guy. This is the difference of squares. And so remember, I'm factoring over the reals. So I can write this as follows. Let's take the square root of this guy. And so x squared plus 2 minus, take the square root of this guy. Oh, the square root of 2x squared is radical 2x. And then multiply by the same thing, except you change this minus to a plus. And so the difference, the product of the sum and difference in two terms is the difference of their squares. Okay, so now let's just write this in descending order. So this is x squared minus x rad 2 plus 2. And this is x squared plus x rad 2 plus 2. And I have factored this completely over the real numbers. Any questions about that? Okay. So oops, I forgot to change that page number. But in problems 15 through 80, solve the equation. Problem number 37. Z, oh, I should also write this. I'm done. Z times z squared plus 1 equals 3 plus z cubed. Okay, so let's try to solve this equation. In general, students like to solve equations, and they're not very fond, however, of simplifying expressions. And so they're not nearly as fond of doing this as
Professor,
compared to solving. Yes, question.
I know you're recording, so are you gonna post it on Canva?
Yes, yeah. So usually what would happen is that you could go to the cloud recording and view the recording there. What I will do instead is I'm going to go to Canvas and I'll just post, like here or something at the very top. I'll just post the video of this. You know, I'm going to upload it to YouTube, and then I will upload it here. Unfortunately, the hard part, the slow part is YouTube. So YouTube, it's a 2.5 hour video. So with YouTube, it takes 3 times as long to download it as the length of the video. So that's 7.5 hours. So it takes for each of these, it's going to take 7.5 hours. That's just to upload it, and then I've got to do things with it. So it'll be sometime this weekend. So by sometimes this weekend, and again, it's the fact, I don't know why. Well, I do know why YouTube is doing that. They want money from you. They want you to purchase so that you'll get priority. But you know, if you do it through the free account, it takes forever to do any video that's long, and so it's going to take me a good part of a day just to upload from Zoom to YouTube, and then back from YouTube to Canvas. So it's a good day's experience there. So I will try to have it available sometime this weekend, and hopefully they will respond to me and Mario and allow us to do some changes with Zoom so we can actually have a actual Zoom link, my Zoom link to this class. We have a Zoom link, but the Zoom link has Mario, I'm sorry, Mr. Martinez, has it where he's the host, and that unfortunately makes me unable to share. I'm not able to share the screen or anything else because of that, and he can't access it. So because of all that technicalities, I'm not able to give you the Zoom link yet, but I will over the weekend sometimes after they decide. It's not really anything technical. They just have to give us privileges back to be able to do these things. Okay, assuming that they are allowed to. It's a huge bureaucracy involved in all of this. Okay, so yes.
Has the first video been posted or not?
The first video has not been posted. The first video wasn't posted due to the fact I just got yesterday, I think. I just got access yesterday to to Canvas. So I have not posted that yet, but I will post that. So I will post the first video, you know, Tuesday's video and Thursday's video embedded in the Canvas. Okay. Okay. Any other questions? Okay, so let's solve each equation. So problem 37. Z times z squared plus 1 equals 3 plus z cubed. So first simplify. Multiply the z inside the parentheses. So I get a z cubed plus z equals 3 plus z cubed. Subtract z cubed from both sides of my equation. So I have z equals 3, and I am done. Any questions about that? So I've solved for z. It looked much harder than what it is. And it has the benefit that also students seem to love solving equations, and they are not fond at all about simplifying expressions. But somehow, when they see, oh, I'm supposed to solve it and get a number, all of a sudden, everything's clear. And they say, oh, I understand this. You can have virtually the same problem, but you're simplifying, and they can't figure out what's going on. Okay, so hopefully, this is probably clear with everyone because it's solving. Problem 64. The absolute value of x squared plus x equaling 12. Okay, so first off, before I even do that, well, what's the absolute value of -5? What's the absolute value of -5?
5,
5. What's the absolute value of 7?
7,
Suppose I wanted to, oh, actually, let's do it this way. Let's do 5 and 5. Sorry. Let's write that. Suppose I wanted to solve the equation absolute value of x is equal to 5. Well, what numbers for x give you 5 when you input those numbers inside the absolute value? Well, x could either equal -5 or +5. So in this case, x could equal plus or minus 5. How do you solve an equation of the form absolute value of x equals a, assuming a is greater than 0? Then x is just equal to plus or minus a. Let me ask you, if x were negative, what's the solution to that? What is x equal to? Anyone? Give me the absolute value of a number equal, is there a number whose absolute value is -3?
No.
no.
No. Good. So that means no solution. So it turns out that if a were negative, then this would have no solution. Suppose x were 0. If the absolute value of x is 0, then what is x?
0,
0. And there's no other solution. So in this case, it's only 0. Plus or minus 0 is just 0. There is no plus or minus for 0. 0 doesn't have a sign. So, so the only solution to this would be x equals 0. So it's virtually, well, it's what I say here, but modulo, you have to sort of be careful. The other cases, you just sort of it's into it that if we have the absolute value equal to a negative number, it doesn't exist. And if it's equal to 0, then the only solution is x equals 0. So let's do this. So problem 64, absolute value of x squared plus x equals 12. Therefore, what's inside the absolute value is equal to plus or minus this positive number. So it's this case. And so we can try to solve it. And there's really two cases. One when it's equal to a plus 12, and the other when it's equal to a -12. So add 12 to both sides of my equation. So I have x squared plus x plus 12 is equal to 0. Okay, good. Let's try to solve this. Well, I can't factor it, but I can try to use the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So b in this case is 1. So I have a -1 plus or minus square root of b, 1, minus 4a, 1, c, 12, all over 2 times a, 1. And so I have here 1 squared is 1. Negative 4 times 1 times 12 is negative 48. 1 minus 48 is a negative 47. And so x is equal to negative 1 plus or minus the square root of negative 47 over 2. Now, since this is an absolute value problem, I only want real answers. And so it turns out that, well, you know, what's the absolute value of I?
A complex number?
Yeah, so, and the answer is, I don't know. So there is an answer to this, but you probably don't know the answer. So
Is it
it's a norm.
1?
Yeah, it's 1. Yeah, because you take the square root of the real part squared plus the imaginary part squared, which turns out to be the square root of 1, which is 1. But again, that's something that has not yet been covered in your courses, but will be covered in this course. So you don't know that yet. So don't feel bad if you don't know that. I didn't even really write it down. I let it disappear because you have not covered that yet. So we don't want complex numbers. So the answer is I don't want complex numbers because I don't know how to take the absolute value of a complex number. So get rid of the complex numbers. So this gives us nothing. We also had, besides the minus, we had the plus. So x squared plus x equals 12. Subtract 12 from both sides of the equation. So if x squared plus x minus 12 is 0, I can factor this. So I have an x and an x, bring down the plus. This is a monic quadratic. So I bring down the plus, times minus is minus. I want two whole numbers whose product is 12 and whose difference is 1, or 4 and 3. And you write the roots with larger absolute value first. So I'll put a 4 and a 3 here. If I do that, then all the signs are correct. Since the real numbers form an integral domain, then they satisfy the zero factor property. Therefore, x plus 4 is equal to 0, or x minus 3 is 0. Subtract 4 from both sides, x equals negative 4. Add 3 to both sides, x equals 3. So there are two solutions to this absolute value equation. X equals negative 4 and x equals positive 3. Any questions about that? Okay. In problems 105 through 110, use the discriminant to determine whether each quadratic equation has two unequal real solutions, a repeated real solution, or no real solution, without actually solving the equation. So this is to remind us about the fact that we can tell a lot about the nature of the roots of a polynomial, in this case, a quadratic, if we know something about, well, the coefficients and the discriminant. And so let's try to do this. So problem 110. Oops. Two x squared minus 3x minus 4 equals 0. Okay, so the discriminant is b squared, negative 3 squared, 9, minus 4 times a, 2, times c, negative 4. Negative times negative is positive, 4 times 4 is 16, times 2 is 32, plus 9 is 41. And so I have the discriminant is greater than 0. So I'm adding and subtracting the square roots of a positive quantity. I can take the square root of a positive quantity and get a real number. So I'm adding and subtracting a real number. Note, well, I can probably say this also. Note that 41 is not a perfect square. Therefore, this is actually 2 unequal irrational roots, irrational solutions. And they, in matter of fact, they come in conjugate pairs. To unequal, or maybe I should say conjugate pair, irrational solutions. Solutions. That's my answer. So I can tell a lot about the solution. You know, the answer is, well, one root is 5. It's 5 plus or minus the square root of 3 or something. So I know it looks something like this. It looks like some rational number plus or minus the square root of something that's not a perfect square. Of course, this is not the answer, but I'm just saying it looks something of that form, where you have, you're adding, you have some rational number plus or minus the square root of a rational number, which is not a perfect square. Okay, so complex numbers. Recall that suppose I want to solve the equation x squared plus 1 equals 0. Well, bring the 1 to the other side of my equation. I have x squared is equal to -1. Then I have x is equal to plus or minus the square root of -1. And I can't do that. So I'm unhappy. There are no real solutions. But maybe I can define them so that there will be a solution. And so we'll define the imaginary unit, I, so that I squared is -1. So my complex numbers, and I believe later on we'll be defining complex numbers more rigorously, but this is review. So my complex numbers are denoted by the letter C. It is the set of numbers of the form A plus BI, where both A and B are real numbers. A is called the real part of your complex number, and B is called the imaginary part of your complex number. We have that 2 complex numbers are equal. A plus BI is equal to C plus DI if the real parts are equal. A is equal to C, and if the imaginary parts are equal, B is equal to D. The complex conjugate. Suppose Z is equal to A plus BI. Then the complex conjugate of Z, denoted by the fact that I have a line over Z, is just A minus BI. The norm, the modulus, the length of this complex number. Note that we actually many times will use the something that looks like the absolute value. It's not the absolute value, but it's the same notation as the absolute value. Sometimes we put, rather than 1 line, we put 2 lines. And so the norm of Z, the length of Z, is the square root of Z times the complex conjugate of Z is the square root of A squared plus B squared. So if you remember, I was asking you, what's the absolute value of I? Well, there is no absolute value, but the norm of I is the square root of the real part. There is no real part, plus the imaginary part squared. Square root of 1 is 1. So, quote unquote, the length, the norm of this number is 1. It has a modulus of 1. I to the n is, well, it's equal to 1 if n mod 4 is 0. If you divide your number by 4, it has a remainder of 0. It's equal to I if n divided by 4 has a remainder of 1. And so n mod 4 is equal to 1. It's equal to negative 1. If n mod 4 is 2, it's equal to negative I if n mod 4 is equal to 3. And so those are the only possible cases for I to an integer, to a natural number exponent. The principal square root. The square root of negative n is I times the square root of n. And recall your quadratic formula. Ax squared plus bx plus c equaling 0, where a is not 0, has the solution x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's do an example on page 861. Which is probably R61 in the other book. In problems 11 through 58, perform the indicated operation and write each expression in the standard form a plus bi. And so let's do this. Okay, so problem 13, negative 3 plus 2i minus 4 minus 4i. So let's get rid of the parentheses. So I have a negative 3 plus 2i. I have a negative sign outside the parentheses. So I'll change all the signs inside the parentheses. So negative 4 plus 4i. And now let's combine like terms. Negative, so add the real and the imaginary part. Negative 3 minus 4 is negative 7. 2i plus 4i is 6i. And that's your answer. Any questions about this? Really? Okay, so hopefully take these off. I'll get them charged again. I'll have to put them back on if there are interruptions. Okay, so problem 17. Oops. 3 times the quantity 2 minus 6i. So let's just multiply inside the parentheses. And so 3 times 2 is 6. 3 times negative 6i is a negative 18i. What the? For those of you who can actually multiply, the answer is negative 18i. Any questions about that? Okay. That was a revolting development. Okay. Let's do problem number 21. 3 minus 4i times 2 plus I. Okay, so let's multiply that together. So 3 times 2, 6. 3 times I, 3i. Negative 4i times 2, negative 8i. Negative 4i times I is a negative 4i squared, but I squared is negative 1. So negative 4 times negative 1 is a positive 4. 6 plus 4 is 10. So your final answer is 10 minus 5i. Any questions about that? Okay. Problem number 29. So 6 minus I over 1 plus I. So I want to somehow get rid of the I in the denominator. I'll do that by multiplying by the complex conjugate of the denominator. And so I'm going to multiply and divide by the complex conjugate of 1 plus I, which is 1 minus I. So I'll both multiply and divide by 1 minus I. And now let's simplify. So I have 6 minus 6I minus I minus and minus become a plus I squared. 1. So this is the product of the sum and difference two terms, which is the difference of their squares. So I get 1 minus I squared. I squared is negative 1, so minus I squared is plus 1. I squared is negative 1. Negative 6I minus I is negative 7I. 5 minus 1 is 4. 1 plus 1 is 2. Therefore, my final answer is 4 divided by 2 is 2 minus 7 halves I. And I've written my answer in standard form. Any questions about that? Okay. Let me do problem 36. So, and let me do it two ways, I guess. So I to the 14. So problem 36, try to evaluate I to the 14. Well, I can write 14 as 4 times 3, 12, plus 2. By the laws of exponents, this is just I to the 4 times 3 times I squared. I squared is negative 1. I to the 4th is 1, cubed is 1, times negative 1 is negative 1. And that is your answer. Or I could do the following. I could look at 14 mod 4. Meaning, take 14 and divide by 4. And do this like what you did in 4th grade, fourth grade, where you just end when you have a remainder and write out the remainder term. So what happened there? Somehow I clicked on, there it is. Somehow I clicked on something. Okay, so let's divide. So 4 times 3 is 12, minus 14 minus 12 is 2. So the remainder is 2. Modulo tells me, asks me what is the remainder. So after the division, after I divide 14 by 4, what is my remainder? That is the meaning of 14 mod 4. And so in this case, this indicates that 14 mod 4 is 2. So therefore, I to the 14 is the same as I squared, which is negative 1, which is basically sort of what I did here. Any questions about this? Okay. Problem 54. The square root of negative 18. Let's write 18 as, or let's write negative 18 as negative 9 times 2. The square root of negative 9 is 3i times, what remains is the square root of 2. So my final answer is 3i rad 2. Any questions about that? Okay. Problem 29, from physics, uniform motion. A motorboat maintain a constant speed of 15 miles per hour relative to the water. Oh, by the way, please note that the version of the book I gave you was the international version. And the only difference between the American version and international version is that units are in metric. So they'll actually write these in metric rather than in miles and feet and things of that sort. So it's a very minor detail. It's giving you different units, but everything else is virtually the same. Okay, so problem 29. A motorboat maintain a constant speed of 15 miles per hour relative to the water and going 10 miles upstream and then returning. The total time for the trip was 1.5 hours. Use this information to find the speed of the current. Okay, so let's do this. I apologize for my lack of ability on drawing. So all you need really is, well, your graph to give you an indication of what's going on. So it doesn't have to be a perfect sort of representation of a boat. You can just say, well, this is a boat. So that indicates a boat. And this boat is going 15 miles per hour. Okay. So it's going 15 miles per hour. And it travels 10 miles upstream. Okay, so there is some current of the water. I'll let the current of the water be C. And so we are therefore going 15 plus C miles per hour when we go in this direction, and 15 minus C miles per hour when we're going in the opposite direction. The total time was 1.5 hours. And so recall, distance is rate times time. Therefore, time is distance over rate. So let's use this. Well, I know the total time was 1.5 hours. Oh, here it is. The total time is 1.5 hours. And so 1.5 hours, I'll call it 3.5 hours, is equal to, well, the time it takes you to go with the current, so 10 over 15 plus C, plus, well, the time it takes for you to go against the current, 10 over 15 minus C. And then let's solve for C. That'll give us the current. Okay, so let's multiply both sides of my equation by the least common denominator, which in this case is, well, you multiply all the denominators together. So 2 times the quantity 15 plus C times the quantity 15 minus C. And so the 2's cancel. So I have 3 times 15 plus C times 15 minus C. Well, this difference of, this is the product, the sum of difference of 2 terms, which is the difference of their squares. So 15 squared, 225, minus C squared is equal to, well, the 15 plus C's cancel. So 10 times 220 times 15 minus C. The 15 minus C's cancel. So I have 2 times 10, 20 times 15 plus C. And now let's try to simplify this. So 3 times 225 is 675. 3 times minus C squared, so minus 3C squared. 20 times 15 is 300. 20 times negative C is negative 20C. 20 times 15 is 300, and 20 times C is 20C. The 20C's cancel. 300 plus 300 is 600. Let's subtract 675 from both sides of my equation. So I get negative 3c squared is equal to negative 75. Divide both sides of my equation by negative 3. So c squared is 25. Take the square root of both sides of my equation. So c is equal to plus or minus the square root of 25, which is 5. So now the current, well, since we were saying which direction the current was, that meant that we're giving the speed of the current should be positive. And so a positive 5. So therefore, the speed of my current is 5 miles per hour. Any questions about that? Okay. Problem number 36. Working together on a job. Oh, this is a similar problem. Patrice by herself, by himself. Patrice, I still think that's Patrice. Patrice by himself can paint 4 rooms in 10 hours. If he hires April to help, they can do the same job together in 6 hours. If he lets April work alone, how long will it take her to paint 4 rooms? So, first, let me give you some notation. So, let X be the time in hours for April to paint the 4 rooms working alone. Then, let's get an equation. And so, it takes Patrice 10 hours to paint a room. Therefore, every hour, he can finish 1/10 of the room. It takes April X hours to paint the room. Therefore, she can paint 1/X of it per hour. Together, they can paint the room in 6 hours. Therefore, every hour, they can paint 1/6 of the room. Multiply both sides of my equation by 30x. 30x divided by 10 is 3x. X is canceled, so plus 30. 30x divided by 6 is 5x. Subtract 3x from both sides of your equation. So 2x is equal to 30. Divide both sides of my equation by 2. So x is equal to 15. Therefore, it takes April 15 hours to paint the 4 rooms. Any questions about this? Oh, I do see something here. Do we have to copy everything down? Well, it really depends. So I'll tell you. So this is me. So I found that when instructors gave us the lecture notes, and they were all, like I give you, all printed out and everything, and I then had the lecture notes in my hand. At the beginning, I would just, read through the lecture notes, as they were going on, and then add my own comments as, the instructor was doing the work on the board. I found that actually, after class, I didn't retain hardly any of the lecture. So instead, what I did is I first read the lectures before class, and then during lecture, I wrote down as much as I could during lecture. After lecture, I recopied the lecture notes from my lectures and from the given lectures. So meaning, do you have to write everything down? Probably not. However, I found that if you don't physically write it down while I'm talking, write at least something down as much as you can. Your mind wanders. You start thinking about food, you start thinking about this, you start thinking about that, and you're not thinking about what I'm talking about. And so somehow you're forced to think about what I'm doing and what's happening if you write down something. Do you have to write down everything? I wouldn't write down everything. I'm very slow in writing, so I can't write down everything. So I do a summary, and then afterwards I recopy it down, adding stuff, putting in everything else. And actually then right before an exam, what I would do is I'd recopy it again, but then making it more concise. So, because there are a lot of things I then knew what was going on, and I just would write down more or less hints for the lecture notes, so to have it in a more compressed form. So that's what I would do. That's what I did as a student. That is and I found that I was able to retain everything by doing that. So by just filling in the missing pieces from the lecture notes. I was actually quite disappointed. I thought that, oh, good, I don't have to write everything down. And I don't, I'll just follow along with the lecture notes and put in the extra little things that are necessary that I don't understand. And I really thought that would be sufficient. And I was I was surprised and disappointed that it didn't work at all, that I could not remember things. I couldn't recall the lectures and what was happening. And strange, because I still had the notes in front of me, but I couldn't recall the lectures and figure out what was going on without actually having written down things during the lecture. And so I think you need to write things down during the lecture, even though you have all the lecture notes. How much should you write down? As much as you can, but don't worry if you can't write everything down. So meaning, if you can't write something down, you just skip it. So you write as much as you can, retaining what's going. It seems strange that you're like, well, aren't I just not listening to lectures and just writing down as they're doing it? That's what I thought, right? But I found out that somehow you're ingraining, you're putting in your brain what's going on as you're writing and listening, and sort of being forced to summarize what's going on in real time. And then afterwards, by putting in extra stuff, when you put in the extra stuff, it actually, you remember, then I would remember where things were and what I was thinking about at the time of the lecture. And then, I would retain what was going on in the lecture. So that's my little splurge about it. Again, you can take, as with any advice, you can either take the advice or not. Okay. So I'm just telling you my experience as a student. So what happened personally to me and my insights on what happened. Okay. Okay then. So let me do problem number 44. Chemistry. Salt solutions. How much water must be evaporated from 240 gallons of a 3% salt solution to produce a 5% salt solution? Okay, so let's do this. So I have here 240 gallons of a 3% salt solution.
I can't put it on.
I'm evaporating, subtracting water. When things evaporate, the salt remains. You don't have, you're only evaporating water. So you're subtracting a 0% solution. How much? I don't know. X gallons. That's what I want to figure out.
You can find out how to figure this out.
And how much do I want it to have at the end? I want a 5% solution. And how much of it? Well, I started with 240 gallons and an unknown amount, X gallons, evaporated. So what I have remaining is 240 minus X gallons.
I can't
these
get
on.
one for with this.
Okay, so one more hour.
Did you talk to my brother?
So, no,
No,
I'm
you
in,
didn't.
I'm in class.
Well,
okay.
I had to sit
Okay.
down.
Shh, shh. Don't interrupt. Shh. Okay, so.
What am I gonna do? Sit there? I sit there? What is sit there and watch you? What
Okay.
the fuck? I'm telling you,
Okay,
they're
so-
checking their new one now, and I don't know how to put it on.
Okay, so let's try to conserve the amount of salt. So obviously, however much salt we have at the beginning is how much salt we have at the end. The water may evaporate, but the salt remains the same. So let's figure out how much salt there is. So there's 240 gallons of a saline solution, and it is 3% salt. So the amount of salt is 240 times 0.03 minus, well, there are X gallons of a 0% salt solution. That should equal the 240 minus X gallons of a 5% solution. So I have 240 times 0.03, 7.2, minus 0 equals 240 times 0.05, 12, minus 0.05x. Subtract 12 from both sides of my equation. So negative 4.8 is equal to a negative 0.5x. Divide both sides of my equation by negative 0.5. And so x is equal to 96. So therefore, we should evaporate 96 gallons of water.
Stop it.
Interval notation. So first off, let me suppose that A is less than B so that I can write things. So I know which one is bigger and which one is smaller when I write the intervals. So let's first look at the closed intervals. The finite closed intervals. The closed interval from A to B. So it includes, oh, maybe I should make that thicker. It includes everything from A to B. It includes both A and B. So it's the set of all x, so that x is between A and B, and it includes both A and B. And the singleton A, which is just the one number A here. It's a set of all x, so I said x is equal to A. The infinite closed intervals. The closed interval from negative infinity to A. So it includes A and everything less than A. It is a set of all x less than or equal to A. Notice that we include A, but we never include the infinities. So I do not include negative infinity. The closed interval from a to infinity. Again, notice I include a, but I do not include infinity. So this goes from a to infinity. The open intervals. And so the finite open intervals, the open interval from a to b. So it's everything in between a and b, but it does not include a nor b. It's a set of all x such that x is between a and b. The infinite open intervals, going from negative, the open interval from negative infinity to a, the set of all x that are less than a. And so it includes everything less than a, but it does not include a. The open interval from a to infinity, the set of all x such that x is greater than a. And so it does not include a, but it includes everything greater than a. By the way, notice if I write things in standard form, meaning the x is written first, then this inequality tells me the direction of the arrow. So notice arrow, arrow. Well, this is intersection. This is a intersection, so can't talk about that. We will talk about that later. Arrow, arrow. Okay. The half open, half closed intervals. And so the half open, half closed interval from A to B, where we include B, but we do not include A. The set of all x such that x is between A and B, where x is not equal to A, but x is equal to B. So it does not include A, but it does include B and everything between A and B. The half open, half closed interval from A to B, where we're including A, but not B. The set of all x such that x is between A and B, where x is, well, could equal A, but not B. And so again, this is the half open, half closed interval. So it includes all numbers between A and B. It includes A, but it does not include B. And next, the intervals that are both closed and open. So it's closed, so clo, and it's open, so it's open. So therefore, we call it a clopen interval. So these are the clopen intervals, ones that are both closed and open. Negative infinity to infinity, all real numbers. So I don't know how to denote this. It's everything. Next, the empty set. Even harder to denote, nothing. So it's a blank, some blankness there. Absolute value inequalities. So we've seen that once. Suppose A is greater than 0, then the absolute value of A is less, absolute value of X being less than A is the same as saying that, well, X is between plus or minus A. If the absolute value of X is less than or equal to A, this just says that X is in between plus or minus A. If absolute value of X is greater than A, then, well, either X is less than negative A or X is greater than A. Absolute value of X being greater than or equal to A is the same as saying that X is less than or equal to negative A or X is greater than or equal to negative A. Now, for the other cases, when A is 0, A is negative, well, you just sort of look at those cases individually. I'm not going to write them all down. and just intuit which one, if, most of them, the solution either does exist, or maybe the solution is only one number, or maybe the solution is every number. So you have to sort of look at case by case what's going on. But it's easy to figure out what's going on. So on page A81, in problems 59 through 108, solve each inequality, express your answer using set notation or interval notation, graph the solution set. So problem number 63. 3x minus 7, 3x minus 7 is greater than 2. Let's add 7 to both sides of my inequality. So 3x is greater than 9. Since 3 is greater than 0, I could divide both sides of my inequality by the non-zero constant 3, and the inequality will not switch. So x is greater than 3. And so I have here, well, maybe I should. That x is greater than 3. So it's all these numbers. Oh, let's do that one too. It is all these numbers that are greater than 3. And so it is the open interval from 3 to infinity. Any questions about that? Okay. Let me do, this is harder, problem number 78. So I have a 3-part inequality. 3 minus 2x is between -3 and 9. So first off, I want to isolate x in the middle. And so let's subtract 3 from all parts of this 3-part inequality, from all 3 sides. So let's subtract 3. So I have a -6 is less than or equal to, 3's cancel, -2x is less than or equal to 9 minus 3 is 6. Now, this is the hard part. I'm going to be dividing by a negative number. So when I divide by a negative number, everything switches. So let's do the switch, but there are 3 parts. So let's do the switch with these 3 parts. And so -2, let's divide everything by -2. So -2x divided by -2 is x. Let's bring down this inequality over here. So notice that if this was a less than, this would change to less than, and you'd still have the less than or equal to over here. So this guy goes over here. Next, I take 6 divided by -2 is -3. This guy goes over here. And this guy is divided by -2 and goes over here. -6 divided by -2 is +3. Therefore, x is between plus or minus 3. So it's a closed interval from -3 to +3. So it's everything between plus or minus 3, but it does not include positive nor -3. Any questions about this?
None.
Okay. Page 106, problem 106. Absolute value of -x minus absolute value of 4 is less than or equal to 2. So, well, I really can't do anything with this guy. The absolute value of -x minus absolute value of 4 is 4. Is less than or equal to -2. Add 4 to both sides of my inequality. So absolute value of -x is less than or equal to 6. So recall how we solved this. We just said that, well, if I have an absolute value is less than or equal to something, which is positive, then whatever's in here in the absolute value is in between plus or minus this. So I have that negative x is between plus or minus 6. And now let's switch this. So divide everything by -1. Since I divide by negative, everything switches. So 6 divided by -1 is -6. This guy goes over here. This guy goes here. Negative x divided by -1 is an x. This guy goes over here. And this guy goes, well, -6 divided by -1 is 6. So therefore, x is between plus or minus 6. And so my answer is, well, it is the closed interval from -6 to +6. Closed interval. Why do I have it as an open interval? I don't know. It's a closed interval from -6 to +6. And so that is my answer. Any questions about this?
For the
Any
last
questions?
problem, they weren't shaded in either.
Pardon?
For the last problem, they weren't shaded in either.
I know, but I shaded them.
Oh, okay.
That's right. And that's because that was an error. So there was an error. Somehow I didn't shade them, you know. So somehow there was no shading there, but there should have been because it's a closed interval. I include -6 and I include +6. So they should have been filled in. Any questions about this? Okay, so that finishes off section R2. So any questions on section R2? The essentials of algebra before we actually start to do things in pre-calculus.
Will there be
Okay.
any homework on the reviews?
Any work on the reviews? I didn't put any. I didn't put any work on the reviews.
Also,
You should.
what's
I
the
mean,
code
I
for
think that's.
Pearson?
So I would say that that's up to you, because it's a review. So every person is going to be different. These are things you should know. So if you don't know it, then work on them. Okay. If you don't know them, then work on them. Okay. Hey, what were you asking now?
For Pearson, we need a code for it.
Yes. So
It's on the syllabus.
what? Yes. So I haven't set it up yet. So I have not set that up yet. And the reason is, again, I only got access to it relatively recently. So I haven't put the access code yet to set that up for you. So I will set that up. But please note that a cost is associated with that. And so there is a cost associated with that. And again, this weekend, I'll catch up since, again, I only got access to this yesterday. So I haven't filled everything up yet. Okay. But you can still do all the homework from the book. Okay. Actually, let me just see something. Oh, no, I don't, huh? Okay. So let's continue. Oh, and let me check. I'm sorry, I forgot to check. No, there isn't. Let me continue with review section 3, geometry essentials. So Pythagorean's theorem. Pythagoras was a leader of a religious cult. They their religion was based in things like logic. They believed in the order of things. And so things like music, there was, they believe that, there is a religious aspect to music. And there was this relationships between music. As a matter of fact, if anyone has taken music before, they gave you the first people to study music systematically with the Pythagoreans. And well, they found that, if you have a string instrument and you shorten the string by half, well, I forget what it was, 1 octave, whatever. So they're the Pythagorean scale for music. They also studied, well, astrology, astronomy / and geometry. And so, they believe that numbers had a mystical, religious quality to it. And also different foods had a mystical, religious quality to it. And so, legumes were holy. So they ate a lot of beans. They were a secret society. And so they lived in caves. They were vegan. They were actually vegan, I believe, because eating of meat and other things were unholy. And one of the things that they did in geometry was, well, Pythagorean theorem. Now, and so, of course, the Chinese did this earlier, but they're Chinese, so we don't recognize them. So there was actually Pythagorean theorem that was done a few hundred years before the Pythagoreans, but for some reasons we just don't acknowledge. We note, oh, and the Chinese did it a few hundred years before, and as a little subnote. So the Pythagorean theorem: a squared plus b squared equals c squared if and only if the triangle is a right triangle whose hypotenuse, the hypotenuse being the side opposite the right angle, has a length of c, and whose sides, which are the other legs of this triangle, have lengths a and b. Some geometric formulas for, let's first look at a rectangle. The area of a rectangle is, well, length times width, base times height. And the perimeter, the distance around your figure, is L plus W plus L plus W, 2L plus 2W, twice the length plus twice the width. A triangle. And so, well, I'm going to give you several. Oh, I'm only going to give you those. And so, suppose that the length of this side is A, the length of this side of the triangle is B, the length of this side of the triangle is C. And suppose the height of the triangle is H. The distance from one vertex to the opposing side, and the distance being the shortest distance from the vertex to the opposite side, meaning it's at a right angle. And so that line here is at a right angle to the base. And it has a length of h. Then the area of a triangle is 1/2 base times height, 1/2 bh. The perimeter is, well, a plus b plus c. The circle is, well, the area of a circle is pi times the radius squared. This is the radius of a circle being the locus of all points equidistant from a fixed point, that equal distance called the radius, and that point being called the center of your circle. If I take a line from one point on the circle to the other point on the circle, passing through the center, then we call this a diameter. which turns out to be twice the radius. The perimeter of a circle is not called a perimeter. So for strange reasons, the perimeter of a circle is called its circumference. And so the perimeter, circumference of a circle, is 2 pi r. Oh, I guess I should tell you, what is pi? And so pi is the ratio of the circumference of a circle to its diameter. And so the circumference is pi d. A rectangular parallelepiped, a box, is, well, suppose that the length of this side is L, the length of this side is W, the length of this side is H. Length times width times height. Then the volume of a rectangular parallelepiped is length times width times height. The surface area is, well, the area of the front, LH, the area of the back, LH, so that's 2LH. The area of the side, WH. The area of the other side, another WH, so that's 2WH. The area of the top, let's see, the area of the bottom, LW, plus the area of the top, another LW. And so this is 2LW. So therefore, the surface area of a rectangular parallelepiped is 2LH plus 2WH plus 2LW. A sphere. So again, a sphere is the locus of all points equidistant from a fixed point, equidistant from a fixed point called the center of your sphere, that distance being called the radius. And we do this in R3. And so this is a sphere. The volume of a sphere is 4/3 pi r cubed. The surface area of a sphere is 4 pi r squared. A right circular cylinder whose base has radius r and whose height is h has a volume of, well, area of the base, pi r squared, times the distance you travel in space, h. The lateral surface area, meaning only the sides. So I assume that this is a tube. So I have a tube here, you know, maybe I have paper towels, and, you know, after you've gone through all your paper towels, you have this little tube that remains. And I want to figure out, well, what's the surface area of that tube? That's called the lateral surface area. And it is, well, the circumference of your base, 2 pi r, times the distance that you travel, h. So 2 pi r h. If you included the top, you'd have to add to this a pi r squared. If you included the top and bottom, you'd have to add to this 2 pi r squared. So this is without a top or bottom. This is merely the sides. Oh, there you go. The top has an area of pi r squared, and the bottom has an area of pi r squared. So a cylinder with both top and bottom has a surface area of 2 pi rh plus, well, the area of the top and bottom, 2 pi r squared. Congruent triangles. Two triangles are congruent if each pair of corresponding angles have the same measure and each pair of corresponding sides are of the same length. Determining congruent triangles. Angle, side angle. Two triangles are congruent if two angles are equal and the lengths of the corresponding sides between the two angles are equal. And so if I have here an angle, a side, and then an angle, and if this angle is equal to this angle, and this length of this side is equal to length of this side, and this angle here is the same as this angle, then these triangles are the same. They'll have all the same angles and all the same lengths. Side, side, side. Two triangles are congruent if the length of the corresponding sides of the triangle equal. And so if this length A is equal to this length B is equal to this length B, and this length C is equal to this length C, then these two triangles are the same. They're congruent. Side, angle, side. Two triangles are congruent if the length of the two corresponding sides are equal and the angle between the two sides are the same. So the length of this side is the same as the length of this side, and the angle in between these two lengths are equal. And if this length is the same, then these triangles are the same. Any questions about this? This is sort of the basis of some things we're going to be doing with triangles when we start doing things in trigonometry. Here's a question. Are most people taking Math 240 congruently? Or have you taken Math 240? Oh, I should have asked that in the math experience. I should ask that. I should have that as a extra question. Okay, so actually, by the way, yeah, I should think of do that now. I should do that later. You should fill in, do the following. Basically, there's a quiz, but it just sort of says, what is your background? You know, what math classes have you taken, et cetera, et cetera. So I should include on that if you're currently taking Math 240, or if you've taken it previously. So let's just see by a show of hands. How many people have taken Math 240? So that means that everyone is currently taking Math 240. So that's my assumption. Since if you have not completed 240, you must be taking Math 240 concurrently to take Math 260. Is that a correct assumption?
I've taken 240.
Oh, okay. So you've taken Math 240.
Yes.
Okay. So at least one person has taken Math 240.
I have also
Okay,
taken
good.
it.
So some people have taken Math 240. But it seems like the majority of people are.
I've taken it as well.
Pardon?
I've taken Math 240 as well.
Oh, you have to. Okay, so there's several people that took 240. Okay, so I guess there's several people that took 240. Okay. But again, I should ask that question. Oops. Okay, so I should ask that question here under math experience. So I'll ask that. I'll change that. So don't anyone take that until later, until like 7:30 p.m. So don't take it until 7:30 p.m. You should take it after 7:30 p.m. Take the math experience, which just asks you things like, you know, what classes have you taken, et cetera, et cetera. What's your hobby? You know, what do you like? What don't you like? Basically, nothing too difficult to answer. Okay, so you used, for those people who took Math 240, you use these facts to determine the angle, to solve triangles, to find all the lengths of the triangles and all their angles. Okay, so similar triangles. Two triangles are similar if the corresponding angles are equal and the lengths of the corresponding sides are proportional. So determining similar triangles. Angle case. So two triangles are similar if two corresponding angles are equal. So angle A is equal to angle A, angle B is equal to angle B, then these triangles are similar. They're not the same triangles, they aren't congruent, but they are similar. They look the same, it's just that I basically stretched this guy. So I just took this guy here and I stretched it to make it bigger. I took this triangle. It doesn't look like a triangle, but this triangle here, and I moved it, but resize. I can make it, voila, it's a similar triangle. So this is a similar triangle because, well, all I'm doing is stretching it. And so it's a similar triangle to what I had from before. Side, side, side. Two triangles are similar if the lengths of all three sides of each triangle are proportional. So suppose that this is A, then this is KA. If this is C, then the length of this side is the same K times C. And if this is B, then the length of this side is KB. So I've multiplied each of these sides by the same number K. If I do that, then these two triangles are similar. Side, angle, side. So two triangles are similar if two corresponding sides are proportional and the angles between the two sides are equal. And so the C's here, the angle C's here are equal. If this is A, then this length of this side is KA. If this is B, then the length of this side is KB, where the K here is the same. And so if this is true, then these triangles are similar. So on page A19, in problems 13 through 18, the lengths of the legs of a right triangle are given. Find the hypotenuse. So problem number 17. So A is equal to 7, B is equal to 24. Well, A squared plus B squared equals C squared. So 7 squared plus 24 squared, 49 plus 144 times 4, 576 is 20. Is 625. Oh, I know what the square root of 625 is. It's 25. And so the length C, the length of hypotenuse is 25. Any questions about that? Okay. Problem 31. Find the area A and the circumference C of a circle of radius 5 meters. And so I have here that the radius is 5 meters. And so the radius here is 5. Well, I know that the area of a circle of radius r is pi r squared. Therefore, the area is just pi times 5 squared, 25. So this is 25 pi square meters. Let's find the circumference. So the circumference of a circle of radius r is 2 pi r. And so I have here, well, 2 pi times 5 is, well, 2 times 5 is 10 pi. So the circumference of the circle is 10 pi meters. Any questions about that? Okay. Any questions about geometry? Okay, polynomials. And so section 4 of the review, polynomials. So a polynomial in in X. So a polynomial in X is just some linear combination of X to some power. And so it's the sum I equaling 0 to n of a sub I x to the I, where these a sub i's are in some field, such as the real numbers. And in here is some whole number. If the leading order coefficient, a sub n, is not 0, then the degree of this polynomial is n. We denote a polynomial where the coefficients are in some field f, well, or in some set f, as p of x, a member of f of x. Sometimes we just write p because the x is already there, and really there is no x. Okay, so terms. The term of a polynomial is, well, each of these are terms. And so we add up a whole bunch of terms. Each term consists of, well, a number, the numerical coefficient. So this number is said to be a coefficient, or a numerical coefficient. And, well, the things that involve variables, the variable part. And so I have a numerical coefficient and a variable part. Of course, sometimes you can just have a numerical coefficient, and then the variable part could be 1. The degree of a term is the sum of the exponents of the variable in the term. So, for example, the degree of the term negative 5a b squared c to the 4th is, well, 1 plus 2 plus 4, 7. So the degree of this term is 7. The degree of a polynomial is the largest degree of any term in the polynomial. Denoted by the degree of p. Let me give you some terminology. If a polynomial only consists of one term, it's that, then we call it a monomial. If the polynomial consists of two terms, we call it a binomial. And so, 3x squared plus 17x. This is a binomial. If the polynomial consists of three terms, we call it a trinomial, bi, tri. And so mono, bi, tri. So it's pretty obvious what these mean. And so, 3x squared minus 7x plus 4. So this is a trinomial. It consists of three terms. The term with degree 0 is called a constant term. And so, 3x squared plus 7, well, 7 is the constant term. A term of degree 1 is called the linear term. A term of degree 2, quadratic term. Term of degree 3, the cubic term. Term of degree 4, the quadratic term. A term of degree 5, the kentic term. The leading order coefficient is the coefficient for the term with the largest degree, sometimes denoted by leading order coefficient of my polynomial p. We say that a polynomial is monic if the leading order coefficient is 1, such as x squared plus 7x plus 2. This is monic because the number in front of the x squared is 1. Examples. Determine whether the given expression is a polynomial. If so, tell whether it is a monomial, a binomial, or a trinomial, and give its degree. And so I have here 5xy minus x cubed. Well, yes, this is a polynomial. It consists of two terms. Each of these terms consists of some numerical coefficient and some variable part. This variable part consists of a variable to a whole number exponent. X to the first power, y to the first power, x to the third power. So it consists of two terms. Therefore, this is a binomial. And the degree of this term is 2. The degree of this term is 3. Therefore, the degree of this polynomial is 3. Example 2. This is a weird one. 0. The answer is yes, it is a polynomial. There is, well, one term. And this term is, well, 0 times some variable part. So yes, it's a polynomial. How many terms are there? Well, there's only one term. So this is a monomial. Now, what is the degree of this polynomial? Well, I can say anything I want. The usual agreed upon definition is the degree is negative infinity. Because we want this degree here to be less than any other degree. So we sort of go overboard and say it's negative infinity. So here's a question. We have 1 minute. If I look at the polynomial 12, it is, yes, a polynomial. It is, yes, a monomial. The degree of this, however, of this polynomial is 1. Is 0, sorry, is 0. So the degree of this is 0. So notice a constant, but a special constant, 0. We give our degree as negative infinity. For all other non-zero, we give it the degree of 0. So that's just a notational sort of property. Okay, so any questions about anything? If not, it looks like that's about time. I believe that does say 6:30. Yes, it does. Okay, so let's see if there are any questions. No questions. Okay, so in the next 15 minutes or so, you should complete the math experience assignment. I will also, I guess, give a small little assignment, maybe in the next half hour or so, just to, let's say by later tonight, I'll give you a small assignment so that you can practice some of these, some of these things. So I'll give you a short assignment that is due sometime before Tuesday. Now, with any sort of due date associated with me, it is a very fluid due date. It is a due date that you should adhere to, but will not be penalized if you go past the due date. Any questions about anything? If there are no questions about anything, then that's it for today. And I'll see you guys on Tuesday.